Okay, somebody on the forum here built this here circuit here, and they was wondering if it's going to work or not. And they said they simulated and it worked for them. And everybody here on the forum so far has been saying that this circuit's not going to work. And I agree. I don't think it's going to work either, because the voltage drops across the diode, and you have all these voltage drops across the base emitters here, that you don't have enough voltage drop for the this last NPN right here. And by analyzing that way there, I would agree. However, I decided I was going to simulate that on my CAD program. And when I simulated, it worked. I got a base voltage here, and I was getting current flowing through there. And I thought, well, something's wrong here. I'm going to go ahead and actually build it and actually see what it goes on here. So I built it. All right. And I'm only using one row of 5 LEDs here, capacitor for the delay. I built it with the same value resistors, only I had to use 5.1K here because that's my 5% or my 10% resistors I have here. 5.1K, 4.7K, 10K for the collector up here. Everything's built according to topology on the thing here. Now, I have my 15 volts. We'll get this here set up here. 15 volts on the supply. Alright, so there's the 15 volts on the supply. So that's there. Now let's okay, so now what I'm going to do now is I have this hooked up to a potentiometer here that will give me my 2.3 volts. The 2.3 volts that we have here, I have a potentiometer set up here, right here. And that potentiometer is set up right here on the outside of the diode here, so we can produce 2.3 volts in here, and that's what this here is set up here for. So I'm going to go ahead and hit this for, turn this on to a 5K pot right here, and a what I come out here, 2.7K, around 2.7K fixed resistor here, so I can apply 2.3 volts to the diode here. So I'm going to bring this up to 2.3 volts now, 0.4, 0.5. Right there is 2.5. Let's bring it down to 2 volts, 1.9. Well, look at that. At 1.9 volts, let's see what we have here. If I bring this down lower yet, right there at 1.4 volts. If I'm going to start increasing it now. 1.6 volts. All 5 LEDs are lighting. At 2.3 volts. Look how bright that is at 2.3 volts. 2.36 volts. Look how bright that is. Okay, well, it does work, just like the simulators were showing. So let's take some voltage drop readings across the diodes and base emitter junctions, and let's find out what that base voltage is on a third transistor. That's what I'm curious about. What's that base voltage on the third transistor? Because that voltage should not even be anything there. Again, we have our 2.3 volts coming in. Here's the base voltage now at that third transistor, 0.686 volts. Okay, I'm going to put this on a stand, this camera, so I can take some voltage measurements. I'm going to show voltage measurements across the diode and the base emitter junctions of each one of these transistors now. Okay, here we go on the base of the... Okay, let's go ahead and take a voltage measurement again. First of all, at the inputs, we've been moving that around. Let's just take a voltage measurement there first. Alright, here's the input. And let's get that back to our 2.3 volts. Okay, there's let's go down below 2.3 just to, there we go. Alright, 2.26, alright, now you can see it. Can you see the lights? Yeah. Okay, let's go ahead and take voltage measurements now. Oops. That was my finger across the diode. Hey, that's pretty nice, that capacitor on there. Okay, so let's take a voltage reading across the diode here first. Hope you can see this here up here. Okay, voltage reading across the diode. Ooh, see, every time I touch that, the capacitor is charging, discharging. Okay, Now, let me get rid of the capacitor. That's 2 volts across the diode. Across the diode now. Okay, across the diode. 0.4 volts across the diode. Okay. The base emitter of the first transistor here. Let me see, emitter base collector. So the emitter, so I got the transistors going the other direction, so I can see how everything's. All right. So base here, base emitter, 0.4 volts. Emitter here. Base 0.5 volts. The last transistor, and I have it going this direction. Emitter on this side. Emitter. Base 0.697 volts across the base emitter of the third transistor. From ground to the base of the transistor, of course that would be the same because this here emitter is grounded according to the according to the schematic. The emitter is grounded, so we're getting 0.7 volts at the third transistor. On the other transistors, we're getting 0.5 to 0.6 volts. Emitter base 0.5 volts. Emitter of the last transistor 0.4 volts. But I will say this: the circuit is very sensitive to touch, very sensitive. And I guess that's because it's like a Darlington pair. I mean, we've got a lot of amplification. I'm even touching just the base of the transistor resistor here on the going in on the 1K. Even right here on the diode. Look at that. Can you see that? Yeah. Just touching the diode. Wow. Okay, that's the circuit working. I put the capacitor back in there now, and we get our delay. But in this case, the delay is turning off. Whenever I turn it off, it delays going off. I turn it back on again. The delay is when it turns off. Okay, well anyway, there's the circuit. There's proven right there that that it does work. So, thanks for watching. Bye.